Now let's also simulate this this function here that we have this file that we have created, and we're gonna basically write the test bench file. We're gonna code it for simulating the basic module function. So first of all, we need to declare the timescale. So we're gonna write timescale with with nanoseconds and a revolution of 100 picoseconds. Next, we're gonna declare the module name. So we're gonna give it module name is Testbench Basic Logic, and then next we're gonna declare the inputs. So this is a declaration of the signal that we're gonna be used in the testing of the design. So the inputs are declared in reg. So reg type reg. So the first input we have input A and the input B, and then next we're going to declare outputs. Outputs are declared in a regular passive wire, so that cannot be enforced to any value. So outputs, we're going to write wire testbench X for output X, Y, and Z. So basically, so these are the inputs, A and B, and this is our output. So next we're gonna instantiate the module, the test module into our design test module here. So what we're gonna write is the same name of this one, and copy all the inputs and outputs as it's written, but in this file. So we're gonna write basic logic of instantiation name module n. We're gonna give it so our first input on our file is written as A, and our corresponding input to this test bench file is test bench A, and then next we're gonna write input B with its corresponding input B on this test bench file. Next is output X with test bench X, and Y with output Y, and Z. So now we have instantiated our design into a test bench file that we're going to simulate. So this is the module that we're going to simulate. Next, we're going to declare this initial begin. Each initial begin we're going to execute concurrently on all modules. So we're going to have the first initial begin for our time simulation. So let me write first of all initial begin, and let's end it. So we're going to have 200 nanoseconds. So and then so we're going to finish. So this line determines the end of the simulation. So our simulation will simulate until 200 nanoseconds. And then next we're going to write another initial begin, and it's so this is gonna be our initial begin for initialization of our inputs. So input A, we're gonna put is equal to 0, and the input B equal to 0. This is for the input start at the time is equal to 0. Next, we're gonna have this always. So always 100 nanoseconds. So basically what this is doing is creating our input variables the same way as we did it in the wave simulation. So we're gonna put it here at the, we're gonna invert the signal. So basically this is creating a square wave with a period of 200 nanoseconds, and another one is for this, for the input B is for the period of 100 nanoseconds, the B. The always it flips, it inverts this signal each 100 nanoseconds. So, and then in theory it's going to create a wave of 200 nanoseconds, and this is going to create a wave, a square wave of 100 nanoseconds. So now we have created all the combinations for combination for inputs A and input B. And then we're gonna write our initial begin for displaying our results. So we're gonna initial begin, we're gonna end it. First of all, we're gonna write the repeat. So we're gonna repeat this. For example, this repeat begin is just like a for loop. So it's gonna iterate 20 times. We don't need it. I just wrote it, but it's gonna repeat 20 times. So we're gonna display. So each 50 nanoseconds, it's gonna display our results that we're gonna see on the time in the time script. So our first A with this 1 decimal, B, and our output X, E, and Z, and their corresponding signal, testbench A, B, X, Y, and Z. Now we need to put an offset just to make sure the signals are not captured at the switching point. So I'm gonna put 105 seconds, and we're gonna end this module. And then I see here we are missing equal here, maybe equal. Yeah, so let's just analyze and synthesize this. Now, so on the next video, I will show you how we're gonna set up the questa that I'm gonna use this model simulation to display the result of this function.